Welcome to Mastering VMware's vSphere 6. In this chapter, we're looking at Chapter 10, using templates and vApps. So first thing is templates and vApps, well specifically templates, are used to help quickly generate and create additional VMs. The nice thing with templates is you can get a VM where you want it, you can snapshot it, and then it's ready to go. That way, if you need to do another deployment, you don't have to worry about installing updates or installing specific software. If you've done that before you did the template, it's already there. So where I've normally done templates is I will get like a client OS like Windows 7 or Kali, and I'll get it fully updated. I will install all the software that I need, and then I'll snapshot it. I'll make that a template. That way I can clone based off of that image. The nice thing with that is, when I go to make a new deployment, I only have a few updates to make. I don't have all the updates. I will only have the updates from when I made the clone until the day that I actually cloned it out. So it's a faster way to provision new OSs. Cloning is simply a file copy that recreates the VM's config files. Again, by cloning, you eliminate the need to perform a new installation every time. The interesting thing here is you can also do what's called guest customizations. You can do a template or an answer file. A template answer file or just an answer file that you can have generate specific answers. Because you do not want things like a VM having the same MAC address or the same name. You may also want all the VMs to join a domain, or you may want specific settings. You may want to follow a standard naming convention. All of that's doable through the the guest customization. It allows you to do customizations based off of your needs. And the interesting thing here is when you make a clone, you can say, use this answer file. So you can actually have more than one answer file. I actually, in my environment, have 4. That way, depending on what VMs I'm creating, I can have it auto join certain domains, or I can have it auto do certain naming schemes. It depends on my needs. Windows VM cloning uses sysprep. That sysprep will help create a new name and a new IP and new security identifiers. For the Linux-based OSs, VMware leverages an open source tool for the custom installation. Because again, in Windows, the computer name really is not as important as the security identifier that it is masking, but every computer having a unique SID is extremely important. We did this in a lab, so you should be pretty familiar with using the customization. First thing first, where do we go to access it? If you're at the home screen in vSphere, you'd be running the Customization Specification Manager. That will allow us to create our answer files. How do we create a template? You right-click the machine that you want and you do Clone to Template. You can also do what's called Clone to Template in Library or Convert to Template, not just Clone to Template. Clone to Template will make a copy of it. Convert to Template will take that VM and then convert that specific VM to a template. So there are advantages and disadvantages for each one. Make sure you know the difference between clone and convert though. So deploying a new VM from a template, the vCenter server will proceed to copy all the files that comprise that template to a new stored location. When the new VM is powered on, vCenter will do the customization according to the values in that answer file. And that way, the template may clone out a machine that's called server 1, for example. The template may have it rename it, but until the VM is powered on, the customization answer file won't have been used or would not have been used, so the renaming of the VM may not occur until after it's powered on. How do we deploy from a template? Or how do we deploy a VM from a specific template? We have what's called an OVF, an Open Virtualization Format. It used to be called Open Virtualized Machine Formats. But the nice thing here is this is a way for us to distribute VMs in a single, compressed format. It is Distributed Management Task Force. This is a standard format for describing a configuration for a VM. Although it was originally pioneered by VMware, other organizations now use it. So OVFs is a de facto standard for compressed templates other hypervisors do use. OVS templates, what they end up happening is they'll have a manifest file, and this manifest file ends normally in a .mf, and this contains the hash, normally a SHA-1 hash. That way we can validate it. There is typically an OVF descriptor, and that's normally an XML document that contains information about the template, product details, VM hardware, requirements, licensing, as well as a full list of file references and a general description. Lastly, we have a virtual hard disk, which is normally our VMDK file. VMDK is VMware specific, but OVF do support different types of disk formats because, again, it's more of an open standard now, and more organizations are using OVFs, not just VMware. OVF versus OVA. OVF is a template that can be distributed as a single file. It's a compressed format. The OVF specification has strict requirements about placement and order within a OVA archive. Everything is stored in a single file, and it's much more difficult to view them independently of each other, but it makes it a little bit easier to move around. How does that tell us anything about an OVA, though? OVF is not only the naming of the package format standard, but it also refers to the package when it's distributed as a group of files. An OVA, Open Virtual Appliance or application, is typically a single file distribution. Again, both are compressed formats, but an OVA typically is the single format, or the VM as a single file. Moving on, we're getting into more templates and vApps and libraries. So libraries, what are the contents of libraries? This is a way of storing VM templates, OVF templates, ISOs, and other media files that you may need and you may want to catalog separate from your deployed VMs. They can synchronize between vCenter servers so that we can publish once and consume elsewhere type scenarios. Basically, I may want to distribute specific ISOs, but I don't want to use the storage on all of my vCenters. So we can publish them between vCenters and have them pull from specifically one vCenter. That way the files are actually stored one location and they're kind of published or mapped to other vCenters. The content libraries can be local, or they could be published. If they're local standalone, they're only for use for that vCenter. No subscription, no synchronization. If it's a local published, then you're actually publishing a parent or the source library, and then your remote vCenters would subscribe to get the changes off the individual synchronization. So if we have a vCenter in Vegas and we have a vCenter in Sacramento, and we want to manage all ISOs in Las Vegas, we could publish the ISOs to Sacramento. Sacramento will pull that data from the Las Vegas data store. You can publish the libraries privately and publicly, and you can also restrict access based off of certain criteria, typically a password. You can do subscribed automatic or subscribed on demand for the public and private distributions or subscriptions of those libraries. Subscribed content libraries automatically download changes received on all the content as soon as the content is made. But what happens if you don't want to use the bandwidth? What happens if you'd rather wait till someone uses it? For example, I may have a data store in Las Vegas that has a specific version of Ubuntu. I may publish it to Sacramento, but a new version of Ubuntu comes out. So I update my Las Vegas ISO data store, and when will Sacramento get it? We can do it automatically. So Sacramento, once it synchronizes, it will automatically see there's a new Ubuntu ISO there, and it will pull it. Or we can do what's called on demand. It will only download the metadata without any actual payload binary data when a template is requested from this library, meaning it will only actually pull down the updated version of Ubuntu in this example when a VM actually needs it. When you actually go to mount that ISO, that's when it'll actually copy it over, hence the on-demand. Let's move into our vApps. So what's a vApp? A vApp specifically is a way to combine multiple VMs into a single unit. It's not a container, but we're getting close to containers. Combining different VMs into a individual vApp allows vSphere administrators to manage different VMs as a single unit. Very similar to a container, but we can't call these containers. A typical multi-tiered application might have one upfront web server, an application server, and a backend server, a collection of services that make up a specific unit or a specific application. For example, my business has a front-end web database, a front-end web server that's tied to a database. The database is not sitting on the front end, it's sitting on the back end. And also it may call a file server. Well, all of them serve that website. So instead of having to manage the three individually, I can manage them all as a specific virtual app or a vApp. That way, all of them, because they're all serving the same purpose, can be managed a little bit more efficiently. So you cannot create a vApp on a cluster that does not have vSphere DRS enabled. If you want to do clustering, you have to make sure you have vSphere DRS. So creating a vApp is typically a two-step process. First, we create the vApp container. We are not still calling these containers. We're just calling it a vApp container, not a container by itself, vApp container. I'm doing Server 2016 videos right now, and they're very particular with the way that we address containers, so I don't want to get my videos mixed up. So this is a vApp container, and this will also deal with the configuring any of the specific settings. Second, for this two-step process, we're adding our VMs that we need to the appropriate vApp, typically by cloning the existing VMs and then deploying them from a template or creating them from scratch. We could do specific vApp resource allocation, so we can actually assign higher or lower priorities of specific resources reserved for the vApp specifically. So we can allocate resources that are shared between the VMs. We can say reservations. We can say how much is shared. We have finite control of the resource allocations for our vApps. We also have a way to, because all of that's going to be managed as a single entity, we have a way to do a vApp with a single IP allocation. So the IP allocation scheme option allows you to modify how the IP addresses will be allocated to specific children VMs within that vApp. You also have options such as the power settings. So you can do specific groups. You can do all in one group. You can set specific structure, when to turn on, when to turn off, startup sequence, how long it should wait before you start the second group, after the first group has been powered on, things of that nature. Lastly, I'm not quite sure why this PowerPoint does this here, but we have a converter. We can do physical to virtual machines or virtual machine to virtual machine converters. You can import VMs from other environments. You can import VMs from a physical machine, which we did this in a lab several labs back. But this is actually chapter, I believe, 10 in a nutshell. Again, this is templates and vApps. I want to thank you.